Welcome to the Electronics Technology video series from Southeastern Technical College in Vidalia and Swainsboro, Georgia. This video is from the AC Circuit series and is titled Introduction to ELI the ICE. Good day. Reactive circuits are circuits that contain reactive elements like capacitors and inductors. Reactive elements are components that shift the phase relationship between the incoming source voltage and source current that feed the circuit. Some components shift the phase to where the source current leads happens before the source voltage in time, capacitors, while other components shift the phase to where the source current lags happens after the source voltage in time, inductors. There's a person out there that electronics technicians should get to know well. He can help you understand how reactive circuits work. Therefore, he can help you troubleshoot a non-functioning circuit or system. His name is ELI the ICE man. Now let's look at what ELI tells us about an ideal inductor, and that's an inductor with negligible winding resistance. E, that's the voltage on the inductor, comes first. This tells you two important things. First, the voltage on the inductor will lead the current through the inductor by 90 degrees, or it could be stated that the current through the inductor will lag the voltage on the inductor by 90 degrees. Second, the voltage on the inductor can change instantaneously, while the current through the inductor cannot. An inductor opposes a change in the current flowing through it. Now let's look at what ICE tells us about an ideal capacitor. A capacitor with infinite leakage resistance and zero material resistance. I, the current through the capacitor, comes first. That tells you two important things. First, the current through the capacitor will lead the voltage on the capacitor by 90 degrees. Or it could be stated that the voltage on the capacitor will lag the current through the capacitor by 90 degrees. Second, the current through the capacitor can change instantaneously, while the voltage on the capacitor cannot. A capacitor opposes a change in the voltage on it. In summary, we have looked at what ELI the ICE man can tell us about the voltage and current phase relationships right on the inductor and capacitor components themselves. We will use this information to develop and describe the voltage and current phase relationships for series and parallel RL, resistor inductor, and RC, resistor capacitor circuits. Have a nice day.